Mid-February 1943, Sidi Bouzid, Tunisia. Officers from Heavy Panzer Battalion 501 surrounded the vehicle, notebooks in hand. This single, intact and operational American tank, taken during the Battle of Sidi Bouzid, would soon shake the confidence of German engineers. It would reveal an uncomfortable truth, that American automotive reliability, not raw firepower or armor thickness, would redefine the future of armored warfare. Painted across its hull was the name War Daddy 2, serial number USA 3,067,641, built by Lima Locomotive Works, assigned to Company G, 1st Armored Regiment, 1st Armored Division. A German reconnaissance crew drove the tank 350 kilometers across North Africa to the port of Sfax, a grueling 4.5-day journey. The Sherman's engine never overheated. German crews, long accustomed to halting for repairs after even short marches, watched in disbelief as the American tank pushed forward effortlessly through terrain that punished their own machines. At Sfax, War Daddy 2 was loaded aboard a freighter bound for Germany. German intelligence had heard rumors of American mass production efficiency, but seeing the machine firsthand made the reality impossible to ignore. It was the embodiment of industrial power Germany could not replicate, not a marvel of high technology, but a triumph of design, simplicity, and consistency. By spring 1943, War Daddy 2 arrived at Kummersdorf, 25 kilometers south of Berlin, Germany's premier proving ground for all new and captured military vehicles. Every system would be tested, mobility, durability, and mechanical design, under German scrutiny more rigorous than any battlefield ever could be. Teams from multiple branches conducted the initial inspection. They photographed every part, measured every tolerance, and dissected every mechanism. To their surprise, the Sherman's construction appeared almost crude by German standards: simple welds, spacious compartments, and robust fittings. But it worked. The powertrain caught immediate attention. German tanks used straight-cut gears that demanded exact tolerances and frequent maintenance. The Sherman's herringbone gears distributed stress across multiple teeth, providing smooth, durable operation. German engineers had deemed such designs too complex to mass-produce, yet American factories had been building them by the thousands for a decade. Testing began with a series of automotive trials. The Sherman was driven across obstacle courses, steep inclines, and rough terrain. Engineers recorded fuel consumption, temperatures, and stress levels. After each trial, components were inspected for wear. The results defied German assumptions. The tank performed adequately in every category, and excelled in one they consistently failed: reliability. The Sherman's 5-speed synchronized transmission allowed smooth shifting and easy operation. It required no double clutching, a procedure that demanded skill and precision in German tanks. Any American soldier with basic driving experience could handle the Sherman after a few hours of training. The Continental R975 radial engine impressed the engineers even more. It tolerated heat, dust, and long operation without degradation. The cooling and filtration systems were deceptively simple, yet astonishingly effective, particularly in desert conditions. What appeared unsophisticated to German eyes proved to be brilliance through practicality. Albert Speer, Minister of Armaments, attended alongside high-ranking Wehrmacht officers and industrial leaders. Before them stood 3 vehicles: a Panther Osprey D, a Ferdinand tank destroyer, and the captured American Sherman. The demonstration compared their climbing and endurance performance. Its transmission shifted seamlessly, its engine kept steady power, and its driver appeared relaxed, a contrast to the tense German crews. The Panther followed, its 700 horsepower Maybach engine straining noisily but managing the climb. The Ferdinand, weighing 65 tons, stalled halfway and had to be recovered, an embarrassing failure witnessed by the entire German leadership. Reports from the Italian campaign confirmed it could climb mountains German experts had declared impossible for tanks. He noted its power-to-weight ratio and cross-country agility were superior to any German design. A week later, the Reich newspaper cautiously praised the Sherman as a remarkable product of the North American steel industry. The truth spreading through Germany's engineering offices was clear. The American tank was not just competent, it was better engineered for real war. At Kummersdorf, testing continued for months. The Sherman achieved operational endurance exceeding 2,000 kilometers before major maintenance, 4 times greater than early Panthers. transmission efficiency, and final drive durability far outclassed German standards. The Germans dissected every component and found no shortcuts, just intelligent design decisions prioritizing simplicity, interchangeability, and durability. Panther final drives, a persistent weakness, failed regularly under stress. Straight-cut gears fractured, housings cracked. Entire vehicles were immobilized after only 100 kilometers. Decades later, restorers would find original Sherman transmissions still functional after years of storage. By late 1943, German reports circulated internally. They revealed a painful conclusion. American automotive engineering was more mature, its production system far more adaptable. The United States could produce tanks faster, in greater numbers, and with more consistent quality than Germany ever could. The difference lay in industrial culture. America's vast civilian automobile industry had prepared it for war production. Germany's had not. Before the war, millions of Americans drove cars daily. Mechanics and factories already operated on a scale that enabled mass production and rapid repair. In Germany, cars were luxury goods. Skilled specialists were few, and assembly line experience was limited. As a result, German tanks demanded expert maintenance and constant care. American tanks required little more than basic mechanical knowledge. The contrast became disastrous in the field. By early 1944, Panther and Tiger units reported appalling readiness rates, often below 40%. In some operations, fewer than 1 in 5 tanks were combat-ready. At Kursk, only 16% of German Panthers were operational at one point. Even when Panthers improved, reaching around 700 to 1,000 kilometers of engine life, they barely reached 1/3 of Sherman durability. The Sherman's synchronized transmission rarely failed, while the Panther's third gear was so fragile that drivers were instructed to skip it entirely. Pivot turns, routine in Shermans, could destroy a Panther's gearbox. Field experience confirmed the lab results. German units eagerly adopted captured Shermans, often using them without modification. They simply worked. Crews praised their ease of handling, their ability to travel long distances without breakdowns, and their forgiving mechanical nature. During Operation Nordwind in early 1945, the 10th SS Panzer Division incorporated 12 captured M4A3 Shermans into its own regiment. They served reliably until the war's end, something that could not be said for many German tanks. The Maybach engine plant and ZF gearbox factory were destroyed in April, halting tank production for months. When assembly resumed, quality plummeted. Forced laborers sabotaged parts, misaligned components, and clogged oil lines with debris. German tanks left factories already doomed to fail in the field. Meanwhile, American production continued uninterrupted, churning out Shermans in staggering quantities, over 49,000 by war's end. German engineers knew they could not compete, not in output, not in quality control, and not in reliability. The Sherman's various models all shared the same mechanical DNA, simplicity and standardization. The M4A to diesel variant, widely used by Soviet forces, impressed German testers for its fuel efficiency and durability. The twin GM diesel engines ran cleaner and longer than anything German industry could manage. Even the multibank Chrysler, a 57 engine, complex by design, proved more dependable than Maybach engines built under duress. By 1944, Guderian reported Panther reliability had reached acceptable standards. It was a hollow victory, an admission that Germany had spent enormous effort just to reach the starting point of American reliability. As Allied air raids intensified, the German production chain disintegrated. Replacement parts ran out. Field units cannibalized, disabled tanks to keep a few running. The Panther became a logistical nightmare. Many were transported by train to conserve their fragile final drives, often breaking down even during unloading. Engineers reported that 70% of tank losses in 1944 were from mechanical failure, not combat. American tank battalions, by contrast, could drive hundreds of kilometers, fight, and immediately prepare for the next engagement. Their strength was not glamour, it was endurance. A Sherman that fired when commanded was worth infinitely more than a broken Panther left behind in the mud. Even German infiltration units, like Otto Skorzeni's 150th Panzer Brigade, during the Battle of the Bulge, sought captured Shermans for disguise operations, not just for appearances, but because they were reliable enough to depend on during deep penetration missions. Only 2 were obtained, and 1 worked. By January 1945, the German Panzer Commission admitted the crisis openly. Hundreds of final drive failures crippled every tank type, from Panzer IV to Tiger. The troops, one general wrote, have lost confidence in their vehicles. Tanks were abandoned, not from fear of the enemy, but from fear of being stranded. As Soviet armies closed in, Kummersdorf engineers hurriedly packed reports and data for evacuation. Some of the captured Shermans, including War Daddy II, were pressed into last-ditch combat near Berlin. They fought until destroyed or out of fuel, functioning until the very end. The German tanks beside them often did not.